In October 2018, at ReactConf in Nevada, Sophie Alpert, Dan Abramov, and Ryan Florence introduced a new way to write React components. Hooks, as the new API is known, is purely additive. The existing class-based API isn't going anywhere, and for some use cases is still the preferred way to construct components. But for many new components, hooks are a more succinct and organized approach. With the release of You.i Engine 6.0, we've upgraded the version of React Native to 0.60, which brings along with it React 16.8, enabling You.i Engine projects to use hooks as well. In this video, I'll walk through converting a few components from classes to hooks, as well as touching on best practices. This video will assume some familiarity with the Hooks API. If you aren't yet versed with the syntax, check out the introduction video, or give the docs a look over. As a brief summary, they allow function components to contain state, side effects, refs, and context, whereas before they were required to be pure functions of their props. The name hook derives from this ability for a function to hook directly into React systems, which Facebook argues is a more direct representation than the equivalent with classes. Compared to the class approach to state management, hooks are functions which can be reused between components. Users are encouraged to use the primitive hook functions to build up custom hooks geared to their use cases. In contrast to higher order components and render props, this doesn't introduce any component tree overhead. The effect hook in particular obviates the need for most lifecycle methods typical in a class, while also co-locating the setup and cleanup logic. As it so happens, hooks provide React with more opportunities for optimization. So in addition to being more ergonomic for humans, they're more efficient for machines. In the introduction video, Facebook reiterated React's mission to make it easier to build great UIs. This aligns nicely with the mission at UITV's founding, to make technology fun and easy to use, allowing companies to own the glass. With hooks, we can simplify our development experience, which should allow us to provide a better end user experience. Let's learn more by upgrading UI's open source application, RN. You can find it at the link provided below. It's currently the project we use for demos, but it's starting to show signs of age, as we'll see shortly. While upgrading for hooks, we'll also make some best practice improvements. We'll begin with the ToggleButton component, an enhancement to our After Effects-based button ref, which allows it to keep a toggle on and off state. These kinds of components are sometimes referred to as leaf components, in that they don't contain any children, so this is a good place to start. But even there, we'll see that there's good reason to allow children for extensibility. Let's begin by reading over what we have so far in the ToggleButton component. At the top, you'll see some pretty standard includes. We're including React. We're including some things from You.i Engine React. We have our helper timeline class, which we'll be looking at later in this video, and some helper functions from this RN helper class. You'll notice now that we're using TypeScript. So a lot of this is actually type definitions, including this type, which declares the callback type for when the toggle button is pressed. Then here we have the interface for the kind of props that the toggle button will take. And it's a little bit confusing why it extends omit. And we'll look at that later and clean this up. But basically, it is taking ref props, dropping name, and re-adding name as optional so that it's not required. And then you'll see here that we have quite a few props that this toggle button can consume. And we're going to trim these down as this video goes on. But it does take a name. It has an index as part of a group. It has whether or not this button is toggled, which just jumping over to here, you'll notice is also repeated somewhat in the state. So there is a prop toggled and a state toggled. And these two kind of compete with each other. So we're going to resolve this as well. We have three different callbacks. So we have when the button is toggled, when it is focused, and when it is pressed. We have a toggle for whether it is a radio or a Boolean, I should say. You can give it an icon and an icon for when it's toggled. You can give it a title, as in the text that goes underneath. And finally, you can have an optional to indicate that this button should focus when it is mounted. So you'll see here that it's a pretty standard class. It's extending pure component. It takes these props and it has this state. Some of the props have been given default prop values, but certainly only some of them, not all of them. We initialize the state to be index 0. If it is index 0, then it starts toggled. We create two refs, one for the on timeline and one for the off timeline. So these are the animations that play when it is toggled on and toggled off. And we also have the reference to the interior button ref. So really this toggle button is just wrapping this button ref and providing some additional usability around it. So then we have two lifecycle methods. We have component did mount and did update. And on mount, we have this little workaround where if that prop focus on mount was specified, we just do a timeout with no time, but basically this just skips a frame, and that ensures that everything is ready for what we want to do, which is focus manager focus. So this is telling the focus manager to focus on the inner ref, bearing in mind that is the interior button. So with timeout 0, it just means it'll happen next frame. It's a small workaround there. The next one is component did update, where we get our previous props and check if the toggle value there is different from the toggle value that we're getting currently. And if it is, then we do either of checking if it's toggled on, in which case we play on, and if it's toggled off, then we play the toggle off. You'll notice here that there's a Roku condition. That is partly just because Roku cannot play animations in reverse. So in that case, we have to toggle off. We have a simple on focus, which just checks if the value is not null and calls it if we need to. And very similar with on press and on toggle. These are basically identical. And then we also have set state. So when the press callback happens, we also toggle the state to be the opposite of whatever it is. And finally, we have the render. And so this is where we see that button ref that we're wrapping. So this has focusable, which is another prop that I don't think is even mentioned up here. So we're passing through even more props. We have this interesting thing here where either we pass the name or we default it to button nav list. And we'll see here that this component has been over-specified for one of its use cases, which is being inside of a navigation list. And this is part of that problem. So we'll be rectifying that. We assign our ref, we assign our callbacks, and we also assign whether or not it's visible. Then we need to get our toggle on timeline and again, get that reference to it. And we also have an autoplay value, which says that if the toggle value is true, this should also autoplay. We also have this big block here, and we check to see if a title was provided. And if a title was provided, then we also render everything within here. So it's a fragment with 4 components. There's the title and the title toggled, which is in case your text changes from the toggle off to toggle on state, perhaps it bolds or something like that. We have to set it twice. And the same is true for the image ref for whether or not it has an icon. So icon off and an icon when it's toggled. And these are being set by those props. So we have the icon URIs there. And as well, the titles are being set from that prop. And finally, we check for the toggle off timeline and set that into its ref there. So overall, it's not a terribly long class. You'll see here it's 97 lines, but certainly we can trim this up and get it a little bit more focused and generalized. So let's start doing that. Now, before we begin cleaning up, I really quickly want to go over the couple places in the code base that we actually use toggle buttons. The first is in the lander screen, where we have the top level lander composition. Within that, there is a navigation bar, and then the 4 toggle buttons are listed there. And these represent the different navigation sections that we can go to. And you'll see some of the props that we've defined that we just looked at. And then also interestingly, within this navigation bar component, if we look at its render function, it does this funny thing where it checks all of its children and it checks if that child's type is a toggle button. And if it does, it clones it while also adding the following props. So that's where it handles the on press, toggled, focus on mount, focusable, and name. So it's actually injecting more prop values here, which is an interesting pattern. And then the other place, which is not related to navigation, is the video controls. So here we have the one place, which is the play pause button of the video player. And I'm going to quickly open up my RN application here. So this is the entry screen, the lander, and you can see that these are the 4 toggle buttons that we have here. So when I press one of them, I am toggling it on, and it has 2 states. It has the toggled on and toggled off, just like Discover is toggling on and off there. And it also has the red strip indicating focus. So if I were to go into one of these assets, I get the product display page, I go into that. Now I am in the player for that asset, and that play pause button is the second place which we see toggle behavior. So with this in mind, if you were to go through this, I'm not going to bore you with it, but we can essentially see that some of our props are actually not used. So let's clean those up first. So the first of these is radio. As it turns out, this prop is just never used anywhere, so we are going to delete it. The second is on focus. This one is also not used. And on toggle happens to directly duplicate on press. So it's entirely redundant. So we'll get rid of that one as well. And then we just need to clean up the areas that had the use of those props. So we'll get rid of that. We'll go and delete this. And in the render. And I think that's good. So that's a good start. We have cleaned up unused props. The second thing that we can do really quickly is this block of commented code is also never used. So we will very quickly just delete that. So let's begin now on converting our class into a function-based hook component. So I will come here and start us off with a just empty toggle button. This will become our new version, and we'll keep our old version down here for reference. But we will need to add old just so that it's not a conflicting name anymore. And then we will need to take its render value and paste it up top. So there we go. We have our toggle buttons render function working correctly. But you'll notice that everywhere that we have this dot props, it's giving us an error, and that's because this is not defined for function components. It would just be props, which are usually included here. So we need to remove all of those. So we will do that. There we go. So now we have props being referenced correctly, but we don't have our default values. And down here we did the default values with this default props, which is static on that class. The more modern way of doing that is actually to destructure this props argument, and rather than doing props dot on everything, just use the destructured version. So that's what I'm going to do. I'm going to start by replacing this line and format that. So you'll see now that I've destructured all of the props that I care about, and now they're accessible without this dot prop. So I need to remove the props dot in front of everything. So let's do that by selecting everything here and replacing. There we go. So now we have a render function that is returning exactly what we had before, and we have all of our props expanded, ready to be used. Next, let's look at migrating our refs and state out of our class and into our function. Taking a quick tally, we see that we have 3 refs, the 2 timelines and the interior button, as well as 1 bit of toggled state. So to move these over, we are going to use our first hooks. I'll do that by coming here, and let's do the refs first. And we can do our first hook, the use ref hook, to get a button ref, which I'm renaming an inner ref. I think this is a slightly better name. And as well, we have the 2 timelines, and note that because we're TypeScript, we are typing all of these and we're initializing them to null. That use ref is undeclared, so let's add it up top right there. And then we need to fix the references again to this dot. So let's do, this is now called button ref. And these ones we can just delete that. And while we're removing red squiggly lines, let's get rid of this style, which is actually not required. There we go. And that looks good. And now to do the state, we will come here and add it like so. And so we do an array destructuring to get our getter and setter, if those are the terms you're familiar with. And note that this is now using the use state hook, which again we will declare up top. And it needs to be typed as a Boolean. And I've put false here, but I guess if we wanted to be more accurate, this was initialized to whether or not the index was equal to 0. So let's do that. Now, as it turns out, the state that we just added isn't actually necessary. If we look for instances of this.state, we'll see that the only place it's actually used is this one line. So while it was good to add as an example of state usage, we can actually delete it now. So that brings us to the next part of our migration, which will be the 2 component did mount and component did update lifecycle methods. And with hooks, the way that you integrate these is with the use effect hook. So I'll start with this second one. and I'll just come in here and copy the body, and we'll bring it up here, and we'll add it here. So we'll begin with use effect. Great, and we will paste in here. And again, we have the problem with this dot, so let's remove all instances of that. Good. And the second part is that we have a check to see if toggled does not equal previous props.toggled. This is actually handled as a second argument in the use effect function call. So if I come here and I start an array and I use toggled here, this will tell the effect that I am only looking to do this if toggled is a different value. So that means that now I can remove these two lines. And this interior, these two lines here, will be called every time component did mount or component did update. So that's the migration of that method. And for the second one, I can just come here and I've got this one prepared. So this one is very similar. It checks focus on mount and it focuses our button ref. Again, that same hack that we had before. But in this one, I use an empty array, and that signals that there is nothing to compare. So there is no equivalent to component did update. And instead, it's just run once at the beginning, which is the equivalent of component did mount. Now we can remove use state, so let's do that. And next we'll address the onPress callback. So if we look down here about how it was defined, we had the set state, but that's no longer necessary. So really all we're doing is we're calling it if it exists. And even there, we are giving it a default value here of an empty function. So we don't even need to do an if check. So the simplest thing we can probably do is just do a lambda right in line. So let's do that. We can do something like this, calling it with the index. And TypeScript is going to throw an error here saying that it didn't expect this argument. And that's because we defined it here without an argument. So we could do something like this, which would fix it. But we're also getting these red lines here. So rather than do that, these red lines are coming from implicitly having an any type. It's because it doesn't know what we're destructuring from. There's no type associated with this component for its props. So we can do that with something like this, react.functional component and toggle button props. So now this toggle button props interface is associated with all of these types, and it knows when we assign the onPress that we're getting the index correctly. Now that we've successfully transferred all of the functionality out of our class-based component into the functional component, let's just go ahead and delete it. So we can select it and just delete it. So we're almost done, but one problem remains, and that is that components that want to use this function right around here, they want to take a ref to it. And because our component is a function and not a class, it doesn't by default expose a ref. But luckily, React does have a opt-in function for this called forward ref, which allows us to take one of our interior components, in this case our button ref, and forward it out to other classes that would like to reference it for purposes such as animations or focus or things like that. So let's go ahead and add that, and we'll do that by removing this part here that we just added and instead doing forward ref. And forward ref takes two types. The first is the kind that you're going to expose. So that is a button ref. And the second is just what we had before, the props type. So ToggleButton props. Great. And then this is a function. So we have to wrap the whole thing in parens like that. And we get a big long squiggly that it's missing a display name, which is an easy enough fix. We just need to do ToggleButton.displayName equals ToggleButton. We're just giving it a string for when it gets debugged. Great. And then the way that we get the external ref is through a second argument, which we can just call ref. So that is what we would like to attach to our button ref. And we could just replace this with ref, but that would mean that we can't use it as we are here, for instance. So we have a problem where we both want to expose it and use it internally. And while React does have a solution with forward ref for exposing the ref, it doesn't really have a baked-in solution for this particular problem. And in that case, with a little help from the internet, we're going to paste some custom hook logic, and I'll just walk through it quickly. So you can read these comments later. It'll all be open source, but the core of it is this use shared forward ref to do what we were just explaining, having both a ref we can use internally and externally. So we'll take as an argument the one that is external, and then we'll generate an internal one, and we'll use an effect hook to basically merge the two. And so if we're not supplied with an external ref, just return out with nothing to do. But assuming we are, refs come in two flavors. They can either be callback refs, in which case we call the callback function, assigning it this inner ref, or it is a ref object as they're known, excuse me. And we assign current, the interior value of the ref, to be shared with this one. And there is some ESLint ignore here, just because this value in TypeScript is mutable, but we're mutating it. So now that we have this, we can share it with this button ref. So instead of use ref, we will use the name of it, which is use shared forward ref. And instead of null, we will pass this ref. So now this ref is being shared with button ref, which is also being assigned here. And if we save that and go to our lander, you can see now that this is resolved. We do have another error, which is that the index is missing as a prop. So we will solve that one next. The interesting thing about custom hooks is that they're often reusable between your components. It's unlikely that ToggleButton will be the last component that would ever want to have this same property. So let's actually extract it to a custom file of its own, and then we can reuse it if need be. So we'll just grab it all and cut it out of there and make a new file and paste it in here and call it use forward shared ref.ts. And we'll have to include a few things. Good. And then from here, we can just import it. Great, it's being used there, and now we can use it in the future. So the next thing that we want to do is clear out the parts of our function that are too particular to the navigation list. And this will be the last sort of major modification we need to make. And part of that is recognizing that the index is not needed. In the case of the player, for instance, there's only a single toggle button, so there's no need to have an index assigned to it, so we can make this optional. But the name is certainly required. We use it every time here. So let's change this from this omit workaround. We'll just change it to be always required with ref props. Okay, and then this is complaining that name is duplicated, so we'll remove it there. And then what we can do is remove this. And what we'll do to remove this part is extract it so that none of this is required, and instead it will be passed in as a child. So we, as part of being a component, we get the children prop, so we can add that there. And then if we were to come down here and delete this, we can add our children right here. And that allows us to simplify some of our includes as well. We can remove that. We can remove that, and that. All right, so we're getting pretty clean at this point. And the last part now is to come back to our lander and remove this. We are going to just select all of our lines going down. We'll delete that and paste here. So we still have these toggle buttons, but let's extract the common parts inside of them into this toggle button contents, which I'll just put up here. And this is just basically exactly what we extracted from the body of our toggle button class, except now it's on the outside in the lander class where it belongs, and it's being passed in as children. So again, we need to do a few includes. And there we have it. So this one takes the only two things that vary between each navigation item, the title and the URI, and it just sets it up accordingly. And here we have the 4 toggle buttons with their children inside of them. And with that, we have fully refactored our toggle button class to use our hook system. And it did require a bit of a workaround with this shared forward ref. But other than that, you can see that a combination of use effect, there was no need for state actually, and a few use refs, and some smart refactoring to move children outside, and just overall cleanup. This class has, or this file I should say, has shrank quite substantially. In fact, there's a few more lines that we can delete there. And that is our first refactor. Let's review our refactor. Granted, a lot of points here are based on general good practices in TypeScript, but it's still useful for review. Firstly, be vigilant about removing anything unused. We saw that the ToggleButton class had a lot of cruft that had built up over time. Likely these parts were used at one point, but as the project evolved, they ceased to be called. We can also look for redundancies, such as we had between onPress and onToggle. For the actual conversion to hooks, we largely just followed standard practice. State became useState, lifecycles became useEffect, and internal refs became useRef. Things got a little bit more complicated when we needed to use forward ref to expose the interior button ref, and further complicated still when we needed to share the internal and external refs with a custom hook. There is another hook, use imperative handle, which we didn't cover. It almost covers that use case we were looking for, but it's more of a facade pattern, which isn't exactly what we're looking for. Nevertheless, you should read up on it to be familiar in case you need it. We also created a custom hook, and it's best practice to extract it to a file so that other hooks-based components could use it as well, assuming we had determined that it's generally useful. As a minor refactor, we have to remove instances of the this keyword, and also bear in mind that we can't store internal state on a this instance. We didn't cover this either, but as it turns out, this use case is also covered by refs. You can read more about this at the official useRef documentation. The modern way to assign default values to props is to destructure the object and assign them in line. We also type our props using functional component and an interface. Finally, as a general best practice, avoid overspecificity in your components by using good old dependency injection with the children prop. Since we covered the toggle button in complete detail, let's look at a second refactor of a leaf component, this time timeline, and see if it differs or if we start to notice commonality. Let's begin as we did before by reading through our class. Timeline's purpose is generally to wrap an existing class called TimelineRef. And if you've ever worked with our After Effects design workflow, you're going to have encountered this, where this is a reference to a piece of animation defined in that workflow, and you reference it by this name property here, and that is the label that it was given in the software. And so what it's really doing is adding promise capabilities to the timeline such that we can use async and await within a function that calls play, for instance, and we can wait on that and then resume some piece of business logic once the animation has completed. And then superficially, it also adds a couple quality of life props. One is play on change, which is just some prop that if this prop changes, play the animation. And we're going to delete this because it's not used. And the second is autoplay and play on true, which is another redundancy, but having one of them is useful to be able to signal this timeline to play as soon as it's ready. So let's begin our refactor and turn this class-based timeline into a hooks functional version. And as before, we will start with just some basic cleanup. So onCompleted is actually inside of our parent prop, so there's no need to redefine it. Same with name. OnChange, play on change is never used, so we'll remove that. And play on true is redundant with autoplay, so we will remove that as well. And then in our default props, we'll just delete these two default values. Don't really need those. The resolve of our promise has a string, which we can see the only instance where it's used is this onCompleted. And turns out nobody really cares for that value. So let's delete that as well. And now that we don't have play on change, we can delete these. Play on true has been replaced by autoplay. And on composition did load and on completed are both potentially null, so we can use the null chaining here, or optional chaining, I believe it's called. And there we have it. So just some small cleanup before we begin our conversion into hooks. Very quickly though, let's just set autoplay to be optional and fix the two places where they should be using autoplay instead. So that would be in the video controls. This play on true now becomes autoplay, and as well in profile. You'll notice here that autoplay and play on true have the exact same conditions, sort of hinting at that redundancy. So delete that line and change this to autoplay. Perfect. Close that, and that. Now to begin converting from this class to a function with hooks, we'll take some of the same boilerplate that we've seen from the ToggleButton example, and I'll start with that. So we are declaring our function timeline as a forward ref, which will export a timeline ref type and take timeline props. Again, I have expanded my props here, and in this case I've used rest to get the rest of them with the spread operator. I've got a couple default values in here. I've got my ref ready to use, and I've got my display name. I'm also going to rename timeline to timeline old temporarily as we are working with it. And then the next thing to bring over will be the render function. So let's do that inside these braces. And I've set a few things here. It's not complete yet, but it's basically just the interior timeline ref. Next, we can take a timeline ref, just like we would have with the toggle button. We were getting a toggle ref, now we're getting a timeline ref. And unlike the toggle button, this one is not the shared forwarded ref. It's just a simple use ref, and you'll see why in a minute. But let's just leave this as a normal ref and assign it here. Good. And then we can also bring over the autoplay effect. So this is covering both component did mount and component did update. And all that's doing is playing and switching the value on whether or not autoplay has changed. So this is the equivalent of checking against previous props. It's called a dependency list. So in this array, you list all of the values that this effect is dependent on. Next, we are going to declare a new type. And this timeline type is going to represent the new interface that our ref is going to expose. Because our old one, timeline ref, it's very similar, but the the play value also now takes seek and returns a promise, unlike this one where play is no arguments and returns void. So this is how we're adding our promise. And basically I've just copied these types and put them into a new type called timeline type. It's the type that I'm going to expose from my timeline. And now it's returning a promise. And I'm going to change this timeline ref so it's not actually returning the timeline ref directly. Instead, I'm going to return this new timeline type. And I'm also going to need to do a few includes. Great. So now we're going to use a new hook that we haven't seen yet called use imperative handle. And what that allows us to do is take the ref that we're getting from forward ref and put it or give it a new interface. So it's kind of like a facade, and we're taking start, pause, abort, and seek directly out of the timeline ref that we just found, and we are just passing forward that function. And we need to do it this way. We can't really use a spread operator because these are defined on the prototype of the class rather than being members of an object. So we do a quick disable because we're using an assertion here that, that they are available. So this says that the ref coming out of here will have these values, but you'll notice that, well, after I import this, that we're getting an error saying that a couple of our types, play and stop, they're missing properties from our timeline type. So TypeScript is flagging us that we're missing two. And to do that, create a ref called resolve, and it's going to have a type of a function which takes no arguments and returns void. And this is going to be the equivalent of this resolve member of the timeline here, which when we create a promise, when we play, we create a new promise, and promises get two arguments. They get the function that you can call to resolve and the function you can call to tell it that it was a failure or a reject. And in the class-based version, we are storing it on the instance of our class with this dot. But recall that because we're in a function component, we don't have access to this dot. So that's another use of refs. We're creating a ref that can store this resolution function. And just as a trick as well, I am using a union type from TypeScript to put union with null, which allows it to return a mutable ref object, which just means that the interior dot current of this resolve can be mutated or reassigned to, which we'll do in a second. So now that we've got this resolve as sort of local state to our function, we can now implement, and I'll just do it one line higher. So we can now implement play and stop. So these were the two major functions that we're creating the promise from below. And they are now within this use imperative handles object that's being exposed. And they're basically the same thing. We're using that new ref that we just created to store the resolution function. And again, we're just doing the same seek or play logic for play, and for stop, same sort of thing. The last thing that we need to bring over from our class is just the onCompleted callback, which resolves our promise and also calls the onComplete callback if there is one. So we'll do that just at the bottom here. And this one is onCompleted inner. I've just named it inner so that it doesn't clash with the expanded one from my props. And I will assign that here, onCompleted inner. So now this resolves our promise. And that is the complete migration from class to function with hooks. But if we look at the result, so starting here and ending here, this result, I wouldn't argue, is much cleaner or more intuitive than the result that we had with our class. And part of that is the size of the imperative API that we're exposing to the ref. We are exposing 6 functions, 4 of which we're duplicating and 2 that we're redefining. And we also have this sort of resolution ref that we need to keep around, which is sort of stateful. And we also need to redefine a type, which we didn't need to do with the class. We could kind of ride the coattails of timeline ref and just expand on it. And so what that means as well is that for classes such as ToggleButton, which we are familiar with now, when we grab a ref to it, we're not actually grabbing a ref to timeline. We are grabbing a ref to timeline type, which then we have to include as a separate type up here from our timeline class. So we have the component in our render function as timeline, but its refs are timeline types, which contain the play, pause, and whatever other APIs, the 6 others. So to conclude, we have to ask ourselves, is it really worth the effort to convert this class to hooks, or was it better left alone as a class? And in my opinion, I would say this one towed the line and probably was a little too far on the side of exposing too much of an imperative handle and requiring too much knowledge of how hooks and refs work for someone else coming along to maintain this, to fully understand it. Whereas the class one is pretty straightforward. It reads intuitively. So it just sort of goes to show that, yes, you can do pretty much everything that you can with classes and hooks, but it's not always worth it. Once again, let's briefly go over the lessons learned. Firstly, when expanding props to assign default values, we can use the spread operator to capture any remaining props to assign children as needed. With the effect hook, its second argument lists props that the side effect depends on. When a shallow compare returns an inequality, it recomputes the effect. This replaces prop comparison in component did update. The slightly mysterious use imperative handle can be used when we want to shape a new API when using forward ref to wrap another component. Define a new type to export that describes this API. We can run into some boilerplate with larger API surfaces, requiring us to redeclare functions. Union refs with a null type to get a mutable ref object. This is important with TypeScript to ensure we're allowed to mutate the inner current value. Ref hooks have broader uses than just referencing components in the tree. They can also be used to store local state. Unlike the state hook, you are responsible for ensuring it is up to date and any changes will not trigger a re-render. Ultimately, some components are not very ergonomic when written with hooks. It may be possible, but consider the overhead you're imposing on other maintainers if you're relying on a lot of trickery to get the job done. This line may change as your team becomes more comfortable with hooks, especially if certain patterns repeat themselves and are documented. For our last example upgrade to hooks, we'll use a non-leaf component with the profile screen. We'll see that with our current knowledge, the process is quite straightforward. Let's begin by looking at what's inside the profile screen. To do that, I'm just going to navigate over to this icon and press enter. You'll see here that we have 3 representative profiles. These aren't actually hooked up to any backend data, so it's going to make our task a little bit simpler. And each of these has both a toggle state and a focus state. So this first profile is now toggled, the second profile is now focused, and now it's toggled. And that's about it. It's a pretty simple screen, and of course it also has back behavior. As before, let's do a read through of the code as it exists as a class-based component. It starts with navigation injected props, which just give it access to navigation, and this comes directly from the React navigation package. And the state simply tracks which index of the profiles is the current active one, which we initialize to 1. It has a focus and blur listener, where focus and blur are terms coming from React navigation to indicate whether or not the screen is currently the focus screen or the top of the stack, and blur indicates when it is leaving the top of the stack. There is the out timeline that we will play as the screen is navigating away, and we keep a reference to the active button that is currently the index that we can focus it. On the mount, we establish focus listener, we establish a listen to the back button press, and on the blur, similarly, we remove the event listener to the back button press. As well, when it mounts, we focus whichever button is currently active. On the dismount or unmount, we will remove these listeners and additionally just make sure that there is nothing listening to the hardware back button at this time. Navigate back is just a simple function that awaits the end of the out timeline And when that's finished, actually pushes the navigation event to the stack. If it's a Roku, it pushes a new navigation event. If otherwise, it's just a simple go back navigation. On press, we set the state to be whichever ith profile has been pressed. And our render is broken up into two parts. First, we construct an array of 3 items, each of these representing the button ref of that profile. It has its toggle on and toggle off timelines, as well as the text underneath, which will say whether or not it is the active user. And then we simply pull in this composition from After Effects. And again, just a reminder that composition is a type that pulls in a full screen worth of information from After Effects. So this is coming from rn_profile. And that's why you'll see that we don't need to declare most of the other items here. We do get a reference to the back button and hook it up to navigate back. We also autoplay in the in animation, and we get a ref instead to the out timeline so that we can trigger it manually. And then we just insert our buttons. And finally, our profile screen is wrapped with navigation focus to pass those props in as we expected. So now let's go through the upgrade process. Again, we are going to set this profile screen to be the old version, just so that we can keep it around for reference. And we won't need this profile state as we're going to redeclare the state, but we will need these props. So we'll begin here by putting in our functional component, profile screen, and it's going to take these profile props. Next, we bring in the state. So instead of being a state object, we simply capture the index as a single integer of state with the active index and profile, or the setter, I should say. Next, we bring in 2 refs, one for the button that is currently the active profile button, as well as our timeline. Then we bring over our render function, which is largely unchanged. The only thing that we've done is we've simplified on press to put it inline rather than have it as a separate function. And this is made slightly easier by the fact that we have a dedicated setter to it now. You'll notice that we don't yet have navigate back. So let's add that. Perfect. And again, this is pretty much unchanged. We will need to import these. Good. And then we bring in our first use effect. And this one is taking the place of the bottom line from our component did mount, this line in particular. And this one is to focus whichever item is the currently focused button so that you have an initial focus when the screen enters. And when you have an empty array as the dependency here, it means that there are no dependencies and therefore it should only really fire once, which is the equivalent to only firing on component did mount as opposed to every time with component did update. So that takes care of our first effect. And then for our second effect, we will add the listener subscription and unsubscription effects. So first, it's the same add listener with focus, and then with blur, we remove it. And then the way that effects work, we return our cleanup logic as its own sub-function here, which will be called when this effect is to be expired. So we remove our 2 listeners. And just like that, we have completed our conversion from our class-based implementation of this screen up to our function-based implementation. And I would say it's a pretty clean implementation. The effects accurately capture the subscribe and unsubscribe logic, and they separate out two separate pieces of side effect. The subscription and the focus are separate concerns, and therefore they're within two separate effects. And so now you can see that it's pretty straightforward to upgrade a full screen. Very little changes between the two implementations. And if you're looking to do a wholesale upgrade to hooks, not the worst candidate. At this point, we've explored most of what we need to know for hooks, but this exercise demonstrated use effect and solidified our understanding. Many of our top-level screen components will wrangle side effects, such as networking, disk use, third-party APIs, and navigation logic. Each of these should have their own hook. Additionally, we can use the return function to co-locate our cleanup logic as a callback of our effect. If our hook effect is only required to run on the initial mount, this can be represented with an empty dependency list, indicating that there is nothing that would make it stale with re-renders. Finally, as we would expect, higher order components such as those provided by React Navigation still work as expected. Thank you for spending the time to learn some of the ways you can apply hooks to your project with UI Engine 6.0. As we saw with the timeline component, the upgrade isn't always strictly better. So use your judgment on whether to convert existing class-based components. Going forward, you may want to consider writing new components with hooks, as they represent the React team's vision for the future and have readability, reusability, and performance benefits. Best of luck and happy coding.